Alright guys, this is going to be the beginning of section 3.6 notes over what we call the chain rule. This will be the last derivative rule that we learn. This kind of completes that list of rules that you have that you've been given on that sheet that I posted on my courses. This is the one at the very bottom of that list of derivative rules. Okay, so before we can learn the chain rule, first we need to learn about, or review, I should say, this is something you've seen in previous classes. We need to review the idea of a composition of functions. Alright, so a composition of functions, the best way to explain it is with an example. We're going to take two functions. We'll say f of x. We'll just say it's a square root function. And g of x. We'll say this is the function e to the x times cosine x. Alright, so we've got two different functions, f and g. And we want to compose these two functions together. Now before we do this, just a quick reminder about how function notation works. If I want to do f of anything, whatever's in the parentheses here, it means you take whatever this thing is and put it in place of the x in the function. Okay, so f of squiggle line is equal to the square root of whatever that squiggly line is. Okay, this is just the basic idea of function notation. Alright, it's important for us to understand this in order to understand how functions are composed together. Same thing with g. If I want to do g of whatever, then everywhere I see an x in my function, I'm going to replace it with whatever that squiggly line represents. So this is e to the whatever times cosine of whatever. Okay. So with that in mind, the composition of functions, the way we write this is we write f circle g. That's not a dot for multiplication, that's a circle. That means you're composing functions. F composed with g of x, by definition, means we're doing f of g of x. Okay, so now the idea is this squiggle here is this function g of x. Alright, so f of g of x means I'm doing the square root of whatever is in the parentheses there, so I'm doing the square root of g of x. Okay, we can be more specific than that though, because we know exactly what g of x is. G of x is e to the x cosine x, so f of g of x, or f composed with g of x, is the square root of g of x. That's the square root of e to the x cosine x. Okay, so that's f composed with g. I'm putting the two functions together. Everywhere I see an x in my function f of x, I'm replacing it with whatever g is. I can compose in the opposite direction. G composed with f of x. Again, by definition of the composition of functions, this means I'm doing g of f of x. Alright, now this would be a good place to pause the video and write down what you think g of f of x should be, and then play the video and see if you got it right. Okay, so g of f of x, again, coming back to this idea up here in the corner, g of whatever is equal to e to that thing times cosine of that thing. Now that thing that's being represented by that squiggly line is the function f. So strictly based off of the idea of function notation, this means we're doing e raised to the f of x times cosine of f of x. Okay, but again, we know exactly what f of x is. It's the square root function, so we don't have to write f, we can actually write the function itself in there. So this is equal to e to the square root of x times cosine of the square root of x. Okay? So if you didn't get this function when you tried it on your own, e to the square root of x cosine square root of x, take a look back, maybe rewind and see if you can make sense out of where that answer came from. If you don't understand what's going on here, it's going to be important for you to reach out to me with virtual office hours or email and try to get this idea of a composition of functions figured out. Whenever we do this composition of functions, something that we'll refer to a lot is the idea of the outer function and the inner function. Okay. In this first example, f was our outer function, and g is our inner function. Okay. In the second example, it's switched. G is our outer function, and f is our inner function. Okay, so what I want to do next is let's just kind of practice identifying the outer and inner function a little bit. So let me give you a function where the two, I've got two pieces that are already composed together. So for example, y equals, let's say, x to the 7th plus 2x plus 1 to the 5th power. Okay, I could think of this as a composition of two functions. The outer function would be, I've got something raised to the 5th power. So my outer function is I've got something to the 5th power. And then my inner function is that thing that's on the inside. It's that x to the 7th, 2x plus 1. X to the 7th plus 2x plus 1. Okay? The idea of identifying outer and inner functions is going to be important for us in the chain rule. One more example of this, and then we'll move on. Y equals e raised to the x squared minus 2x. Now again, pause the video here and think about what you would identify as the outer function and the inner function in this case. Alright, so when I look at this, I see e raised to some power. So in this case, my outer function is just the function e to the x, and then what's inside the function, e to the x, in place of an x, I have this inside function, this x squared minus 2x. Okay, so again, if this idea of outer functions and inner functions isn't making sense to you, please reach out to me and I can work on it a little bit more with you outside of the video and maybe within some virtual office hours. Okay. Now the last thing I want to look at in this video before I actually give you the chain rule itself is just one more little piece that's going to help us understand the chain rule. I'm going to give you a function f of x equals x squared plus 7x cubed, and I'll give you another function g of x is sine of x. Okay, now I've got two questions for you here. First, a pretty straightforward question. What is f prime of x? F prime of x. Alright, so this goes back to just basic power rules here, because f of x, here we've been doing the derivative of this type of function for a while now. F prime of x, we know that its derivative is 2x plus 21x squared. Okay. Now the last thing I'll do here in this video is one more little practice with function notation. What if I asked you to do f prime of g of x? Okay, when we cover the chain rule in the next video, it'll be clear why I'm asking you to do this. But right now, this is, again, this isn't a lesson in derivatives, this is a lesson in compositions of functions. So again, remember, f prime of x is this function up here. F prime of x is 2x plus 21x squared. So if I want to do f prime of anything, it's going to be 2 times whatever that thing is, plus 21 times whatever that thing is squared, right? This is just how function notation works. So now the thing that we're plugging into f prime is g of x. So f prime of g of x is 2 times g of x. I don't know why my pen is acting up on me, but alright, so 2 times g of x plus 21 times g of x squared, right? Whatever's in here in the parentheses, I put it everywhere I see an x. 2 times x plus 21 times x squared, I've got 2 times g plus 2 times g squared, f prime of g of x. Okay, but then again, we know exactly what g of x is. It's the sine function, so I have 2 times sine x. Oh, I left the 1 off on the 21. That's 21 g of x squared. Sorry about that. 2 times sine of x plus 21 sine squared. Okay, so that is f prime composed with the function g of x. Alright, so I'm going to stop this lesson here, and in the next lesson I'll show you what the chain rule is.